This video is for informational and educational purposes only. We do not encourage the construction, use, or distribution of the technologies described. Several of them are illegal under many jurisdictions. Always verify your local laws. DIY tech is empowering. It teaches us about systems, security, and hardware. But sometimes it steps into legally gray or outright criminal territory. Today, we'll cover 7 devices you can technically build at home, but that come with serious ethical and legal consequences. Signal jammer. Signal jammers disrupt radio communication by overwhelming a frequency with noise. Most DIY jammers operate in the 2.4 GHz band, targeting Wi-Fi or Bluetooth. The critical issue? These devices don't discriminate. A jammer broadcasting over 2.4 GHz will interfere with home routers, medical equipment, industrial IoT devices, and potentially emergency services. Even a simple jammer can be built using an RF oscillator, followed by an amplifier circuit that boosts the signal to effective jamming levels. Advanced versions using SDR software-defined radio hardware like Hack RF can sweep across multiple bands with high precision. Jamming violates laws almost everywhere. It can interfere with national emergency infrastructure, disrupt public safety operations, and prevent citizens from calling for help. That's why penalties can include heavy fines and jail time. Raspberry Pi Wi-Fi sniffing rig. With a Raspberry Pi and a USB Wi-Fi adapter that supports monitor mode and packet injection, you can create a wireless packet sniffer capable of intercepting and analyzing Wi-Fi traffic. This becomes powerful when paired with Kismet, an open-source wireless network detector and sniffer that passively collects packets and detects devices. Aircrack, a suite of tools to capture and brute force WPA handshakes to recover Wi-Fi passwords. BetterCap, a powerful network attack and monitoring tool capable of real-time man-in-the-middle attacks, DNS spoofing, and credential harvesting. Wireshark, a packet analyzer that lets users inspect the contents of traffic at every level of the network stack in real time. Why is this dangerous? Because these tools allow unauthorized surveillance of wireless traffic, including tracking device MAC addresses and collecting sensitive handshake information. Even passive sniffing on networks you do not own is considered unauthorized interception under many legal frameworks. These tools are intended for ethical hacking and testing, but in the wrong hands, they become privacy-eroding weapons. 3D printed keys. Key duplication has evolved from physical molds to digital modeling. With a single image of a key, it's possible to recreate its geometry in CAD software and produce a working copy via 3D printing. Tools like OpenSCAD, a script-based modeling language for creating 3D CAD objects, allow you to construct exact key models based on visual input. Combined with a database of commercial key profiles and access to a resin or filament-based 3D printer, users can bypass physical access controls with ease. Why is this dangerous? Because mechanical locks often lack duplication protection. A smartphone photo combined with basic software skills is all it takes to gain unauthorized access. This is a direct breach of physical security and can lead to charges of unlawful entry or attempted burglary. OBD car hacking. The OBD port in modern vehicles connects to the CAN bus, the digital backbone controlling everything from brakes to locks to infotainment. Using an ELM327 interface, a common chip for interpreting OBD data, paired with a Raspberry Pi or a microcontroller like STM32, it's possible to send custom CAN messages to manipulate the car's behavior. Supporting tools include SavvyCAN, a GUI tool for logging and editing CAN traffic. Canalize, used for decoding and analyzing CAN data packets. CAN Utils, a Linux command line toolkit that enables reading and writing raw CAN frames. The threat? These tools can be used to unlock doors, start engines, or disable alarms, all remotely. Many real-world car thefts now rely on CAN injection attacks. Unauthorized interaction with the vehicle's network is often treated as an attempt to steal or compromise vehicle integrity. Magstripe card cloning. Mag stripe card cloning is when someone copies the data from the magnetic stripe on a card, like a bank card or hotel key, and uses that data to make an identical copy. The magnetic stripe holds information such as the cardholder's name, the card number, the expiration date, and sometimes security details. And here's the problem. All of that data is stored in plain text. It's not encrypted. That means anyone with a cheap card reader, which you can get for as little as $20 to $50, can read it. A common device used for this is the MSR 605. It can read the data from one card and then write it to a blank one. It's basically copy and paste for credit cards. Why is this dangerous? Because it's easy, cheap, and still works on many systems. Hotels, office buildings, and even some payment terminals still use magstripe technology. That makes this type of cloning a low-skill, high-reward method for fraud. You don't need to hack anything. Just swipe the card, copy the data, and clone it. And that's why magstripe cloning is still a serious security issue today. USB rubber ducky. A rubber ducky looks like an ordinary USB stick, but it's actually a malicious device that pretends to be a keyboard. And when you plug it in, it starts typing commands instantly at lightning speed. The computer thinks it's just a regular keyboard, but it's being hijacked. There are DIY versions too, built with small devices like the DigiSpark, which runs on a tiny microcontroller called the AT-Tiny85. These can be programmed using simple tools like the Arduino IDE or a scripting language called DuckyScript. The things this little device can do are scary. It can open terminals or command prompts, download malware using PowerShell, and steal data or add hidden backdoors all in a few seconds. So why is it so dangerous? Because it abuses something the system trusts, the keyboard. The operating system allows it in without question. And here's the catch. No antivirus can detect keystrokes. It's not scanning files, it's simulating a human typing. In under 5 seconds, an attacker can gain full access to your machine. Just by plugging it in, rubber ducky devices are often used in penetration testing, but they're also tools for corporate espionage and insider threats. In the wrong hands, they can do serious damage. Fast. Wi-Fi deauth tools. What are Wi-Fi deauthentication tools and why are they dangerous? The ESP8266 is a tiny, low-cost microcontroller with built-in Wi-Fi. Harmless on its own, but with the right firmware, it can become a powerful Wi-Fi jammer. Here's how it works. The device sends out deauthentication frames, special packets that tell nearby devices to disconnect from a Wi-Fi network. These frames are part of the Wi-Fi standard, and they don't require any password or encryption to send. That means no hacking, no cracking, just pure disruption. With firmware like ESP8266 deauthenticator, attackers can scan for networks, choose a target, and flood it with fake disconnect signals, all from a simple web interface using a device that costs under $5. So why is this such a big deal? Because it causes total denial of service. Phones, laptops, even critical equipment instantly kicked off the network. Schools, hospitals, and businesses can lose access in seconds with no visible trace of who did it. And here's the legal part. Even if no data is stolen, launching a deauthentication attack is considered illegal network interference in most countries. It's a serious offense even if it feels like just signal disruption. Simple, cheap, silent, and devastating if misused. Technology is neutral. What matters is how we use it. These projects are brilliant and dangerous. With knowledge comes responsibility. What do you think? Should laws be tighter or is personal ethics enough? Let us know in the comments, and don't forget to subscribe for more deep dives into the gray zones of tech.